Hello there. We are going to do the first section of the book, sections P2 and P3, which are referred to as the prerequisites. Let me go there. And so we are going to start with this. Now, I'm sure that you've done this kind of stuff before in previous math classes, but I'm betting that summer has drained some of the knowledge from your brain, and we're going to try to put some of it back again, because these are fundamental things that you have to know how to do in order to be successful in the class. Okay, so let's get started here, and let me grab a new page. Goodbye, colorful page. Okay, so P2 is about the Cartesian coordinate system. And as you recall, if you have a point, first coordinate is x, second coordinate is y. Whoops. Because these are the axes. X is referred to as the independent variable, y is referred to as the dependent variable. That is not important at all to what we're doing. And I want you to recall the absolute value function, just to make sure we remember, because that is in the book. Right? Absolute value of -3 is 3. Absolute value of 3 does nothing. Okay, but now let's pick another point here. Another x. I'll call this x1, y1, and I'll call this one x2, y2. So that's a bad way to do that. That's okay. So if we wanted to know the distance between these two, yeah, that's still a bad way. Let me do this. Let me move this. Use my little handy dandy lasso tool. There we go. Over to there. Look how high tech I am, I tell you. Okay, stop. Okay, now the next one, we'll grab this one. Oops, I got a little bit of the axis. Oh well. That's the way it goes. I'll put this one over here. Okay, so here's our 2 points. Wait, go away. Pen, yes, okay. So we got these 2 points here. x1, y1, x2, y2. And if I connect them with lines, I can form a right triangle here. And as we recall with right triangles, you got one side, another side, and another side. And Mr. Pythagoras Pythagorean theorem. Is that spelled right? No, there's an E. Okay, there we go. I think. That doesn't look right either. Oh well. So a squared plus b squared equals c squared. And if you're solving for c, you would take the square root of a squared plus b squared. Now, we can do that here by knowing the distance from this point to here is the difference in the x coordinates. So a is equal to the big one minus the little one. And b, likewise, is the difference between the y coordinates, y2 minus y1. So if I plug these into our equation here for the Pythagorean theorem, let's get a pretty color, a little dark green action, there we go. So if I plug them into here, I'm going to get the square root of x2 minus x1 squared plus, and then I'll plug this in for b, y2 minus y1 squared. And oh, look at that. This is the distance equation between 2 points. It's the Pythagorean theorem. It's just the Pythagorean theorem using coordinates. But this is something we're going to use a lot to find the distance between points. Should this be on your little cheat sheet of formulas? Absolutely. The distance equation. Should the Pythagorean theorem be on your little cheat sheet of formulas? Absolutely, because that dude is important and we're going to use it a ton. Should you put the absolute value of -3 on your cheat sheet? Yeah, probably not. I'm betting you can remember that. So let's say we have an example. And so if we have 2 points, 1, 5 and 6, 2. And I ask on a test, what's the distance between them? Well, I arbitrarily choose one of them to be 1 and the other one to be 2. 0.1 and 0.2. And my distance equation is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, when we're looking at this, does it matter what the order is here? Let's see, here's 1 and 6 for our x's, right? So I could do 6 minus 1 squared, or I could do 1 minus 6 squared. Does it matter? 6 minus 1 will give me a 5. 1 minus 6 will give me a -5. Do I care? Absolutely not, because the square is going to get rid of the minus sign. So I don't care which of these I do in whatever order. When I go to try to find the slope of a line, y2 minus y1 over x2 minus x1, that's in the next chapter. When I do this, the order absolutely matters. You got to make sure these two are from the same point and x1 and y1 are from the same point. You get those flipped and you're going to get a negative sign error, and then you're going to be sad. So you got to, when you're calculating the slope of a line, you got to keep track of the order. When you're finding the distance between 2 points, this square gets rid of any problems for us, so we don't care. Okay, so let's plug in our points. Oops, go away, rectangle. So the distance would be the square root of, I'll do 6 minus 1 because I always want to eliminate negative signs. You will find negative signs will be half of your errors in this class. So whenever you can get rid of a negative sign, you should. And this one, I could do 2 minus 5. But I'm going to get a negative. I'm going to do 5 minus 2. No, I'll stick with the order. I'll be good. Okay, so this will be 5 squared. And this is 2 minus 5 is -3. Notice I put the negative sign in parentheses. If you write -3 squared, the exponent acts on the thing right next to it, which is a 3. If you want it to act on the negative, you got to put that dude in parentheses. And this is true on your calculator, and it's true on any online calculator you use. If you want to square -3, you got to put it in parentheses. Okay? Okay, so square root of 25 plus 9. So that's going to be square root of 34. Not a perfect square. The factors of this are 2 times 17. There's no perfect squares in there to factor out, which we're going to do later. So we can't do anything. So square root of 34 is the answer. That's the distance between these 2 points. Okay? Which that turns out, if you do that in your calculator, 5.83. So you can crunch that, I'm sure, on your calculator. If you have trouble knowing how to crunch this on your calculator or how to do it on an online calculator, let me know and I can help you. Okay, so we have the distance formula. D equals square root of x2 minus x1 squared plus y2 minus y1 squared. Now we have another thing. And if I have my points, and this one is x1 comma x2, or what am I doing? That would be wrong, y1. And this one is x2 comma y2. And I have, watch this, I'm going to make a straight line. I always forget about this tool. So I got a straight line between them. Go away, go away. There we go. And I want to know, where is the midpoint of this line? Right, it's going to be somewhere in here. It's going to be half the distance between the two. Now, if we wanted to, we could find the distance and then divide it by 2 and figure out what that is and do lots of math. Or we realize that the midpoint appears at the halfway point between that side of the triangle and the halfway point between that side of the triangle. That's where the midpoint's going to lie. So to find the midpoint, what I really need to do is find the middle of these two numbers. So if I had two numbers, 2 and 6, how do I find the midpoint between those two? Well, I know it'd be 2, 4, 6. I know that the midpoint is at 4, right? We can count. But how do we do it mathematically? Well, the midpoint is the same thing as the average. So in this case, I can do 2 plus 6, I don't need parentheses, over 2. 8 over 2 equals 4. Hey, look at that. So I can do the same thing here. If I want to know what the coordinate of this point is, let's use some dark green. There we go. So this one, the x-coordinate of the midpoint is going to be the average of the x-coordinates. x1 plus x2 over 2. And likewise, where are we at? What's going on here, tablet? There we go. And likewise, for this point, it's going to be the average of the y-coordinates. Oops. y1 plus y2 over 2. And that's it. The midpoint formula is the x-coordinate of the midpoint is the average of the x-coordinates, and the y-coordinate is the average of the y-coordinates. And that's it. You take the 2 points, you find the average of the x's, find the average of the y's, and those are your points that are the midpoint. So let's try an example. Let's say we have the point 1, 4, and 7, 11. There we go. And I want to know the midpoint and the distance. We'll do both. Oh, that'll be fun. Okay, so the midpoint is going to be the x-coordinate of the midpoint is 1 plus 7 over 2. And the y-coordinate of the midpoint is 4 plus 11 over 2. So this would be 8 over 2 is 4. And 15 over 2, we can't reduce. But you could write it, do it on a calculator and say 7.5 if you wanted to do that. And then the distance would be the square root of, now we got to take the difference of the x's. So I'll call this point 2 and this one point 1. So 7 minus 1. I avoid a negative sign there by making 7 the first point and 1 the second. And then 11 minus 7, or 11 minus 4. So that's going to be the square root of 7 minus 1 is 6. 11 minus 4 is 7. So that's 36 plus 49. So that equals the square root. Let's make sure it goes all the way. 85. and that is not reducible. So we could plug square root of 85 into a calculator and get a decimal version. So here's the distance, and here's the midpoint. Okay? Does that make sense? Any questions? Oh, no questions. You all got it perfect. Awesome. Okay. Let's keep going. So it mentions in the book circles. Do we really want to do that? Yep, a circle centered at the origin has the equation x squared plus y squared equals r squared. Let's pause for a minute. Okay, we're back. Yeah, I don't think we're going to talk about circles for that right now. This is just, I'll tell you, it's just saying that the coordinates of this point from the center is just the distance formula. You see, we got 2 points. Everyone are on a circle. You got 2 points no matter where you are. And the distance between the 2 points is equal to the radius. But I'm not really worried about that right now because we are going to spend some time on circles later. Enough where you're going to say, dude, enough with the circles already. Okay, go away. Okay. So that was section 9.2, which was reminding you about Cartesian coordinates. Now, so, I'm sorry, not 9.2, P2. So P3 is about solving linear equations. So this is algebra. And what I've learned in all the classes I've taken in math, which is a lot, the thing that's really important that guarantees success in all the math classes are your algebra skills. If your algebra skills are no good, then you are going to struggle. So it's really important you're good at these, and we need to work on these together if you're not. Practice, practice, practice is how you get these to work. So solving linear equations. So a linear equation looks like ax plus b, right? The equation of a line, which we'll talk about later, equals something. I don't know what. But this is a simple linear equation that we could do some algebra to solve for x, right? And so we just got to practice good algebra skills. We got to know orders of operations to know what we do first and second and third. So here is from the book, example 2. It says solve for x, and it looks like this. Plus 3 times x plus 1 equals 5x plus 2. Now, traditionally, I was not a good mathematician when I was in college. And it really made it difficult when I went to grad school for physics, because let me tell you, the math was hard. It sucked. And I had to learn certain graphical tricks to help me remember what I'm doing and keep track of what I'm doing so I don't make silly little errors like dropping numbers and leaving a negative sign when it should have been a positive sign or something. So I've done a lot of things in order to survive. And one of the things I've learned is when you're distributing, I draw some little pictures here. So I'm going to have to distribute the 2 and the 3 so that I can get rid of the parentheses. We got to get rid of those first, because our goal is to get x on one side of the equation, everything else on the other. So I'm going to distribute there, 4x. I'm going to distribute there, minus 6. And then another one, plus 3x. 3 times 1 is plus 3. That's an x. Equals 5x plus 2. Now, I've done 2 things there. I used these curves so I knew I was doing all the distribution to make sure I did it right. And I also put out a roadmap there for someone who's grading my work that can see what I did right and what I did wrong. Because if you make a silly error and you do this and you draw the arc, but then you write the wrong number here, it's easy for me to go back and see where the mistake is. And when it's easy for me, I'm more likely to give partial credit. If you just write an equation here and I don't know what the heck you did, well, I don't know if you just made a simple mistake or you had no idea how to do it. So you need to make it easy for me to see whether you knew what you were doing or not. Okay, so now I got to combine like terms. So let's see, 3x and 4x. So I'm going to add this one to this one. So that's 7x. And then I'm going to add this one to that one. That'd be minus 3x equals 5x plus 2. Now you see what I did? I'm showing with arrows which terms I combined together so that I know how I did it. So that's a very convenient way to show it. Now I'm going to move the 5x over to here. Oops, this isn't a 3, that's just a 3. And then I'm going to move the negative 3 over to there. Oh, look, more graphical indicators. So 7x minus 5x. I'll add 3 to that side. So notice when the 5x comes over here, its sign changes. So I subtracted 5x. What you can also do, and sometimes if I'm tired, I will do this. I can usually do it for simple things like I just did there. But if I'm tired, I'm going to write a plus 3, and I'm going to write a minus 5x, and then I'm going to add. And we get 2x, that's 0, equals, that's 0, 5. And likewise here, this is 2x equals 5, x equals 5 halves. So doing it so I can keep track of what I've done and make it easy for somebody grading to give me partial credit if I make a mistake is what I do. This helps me to not make mistakes because I have graphical indicators to tell me what I'm doing. And it also makes it easier for somebody grading my work to know what the heck I was doing. Okay, this is a really good strategy. I recommend everybody do this because this is going to help everyone. This is a simple problem. I get it. You can do a lot of these steps in your head. I know that's easy. But when you're stressed and it's on a test and you're tired because you were up all night writing an essay for econ, these kind of things can help you. So please give that a try. I think you will find it's a valuable thing to do. Okay, now inequalities. I heard all the groans there. Oh, I hate inequalities. Oh, they're not that troublesome. Okay, so 2x plus 6 less than or equal to 0. If we want to solve this, and then we'll do another one. 6 minus 2x less than or equal to 0. We'll solve both. So we just treat this as an equal sign. And I'm going to just move the 6 to the other side. And then I'm going to divide by 2, right? Multiply by a half. X less than or equal to minus 6 over 2 is minus 3. Then over here, I'll subtract 6 again. Then I'm going to divide by negative 2. Now the rules for inequalities say when you multiply or divide by a negative, then you have to, flip the inequality sign. So here, when I divide by negative 2, I have to flip that guy around. Negative 6 over negative 2 is 3. This is the rule that people forget. When there's inequality problems on a test or a quiz or something, we don't have quizzes, on a test, I guarantee you there's going to be a negative sign that you're going to have to divide through by, and I'm going to see if you're going to remember to flip this inequality sign around. So this is important to add to your super duper cheat sheet of things you need to know, that you have to flip the inequality sign around when you multiply or divide by a negative sign. What if it was 2x minus 6 less than or equal to, oops, no, I don't need to do that. You can see up here, we subtracted a negative 6 and we did not flip the inequality sign around. When you add or subtract, it doesn't trigger this rule. Only when you multiply or divide by a negative do you have to do that. Okay? So that's really important, and you got to watch out for that. This is why I always watch out for negatives. So let's try another one here. This will be fun. I promise this one will be fun. The last one wasn't that much fun. Oh, this one's fun. Less than or equal to 4 minus 2x less than or equal to negative 1. Now, how much fun is that? Okay, so I need to solve for x. So I got to get x alone in the middle here. So I'm first going to subtract 4, but I got to do it from all sides. So this will be negative 7 less than or equal to, that'll be 0. Whoops, that's an ugly looking x. Less than or equal to minus 5. Then I'm going to divide by negative 2. Uh-oh, dividing by a negative. Alert, alert. 7 over 2 is 3 halves. Well, we'll leave it as 7 over 2. The negative signs will cancel, right? This is going to flip. Minus 2 over minus 2 is x. This is going to flip. And that's going to be 5 halves. So this is the solution to this equation up here. And we had to flip these around because of that negative sign right there. That was the culprit that made you have to do that. I'm looking at the homework stuff, and it's really pretty easy at first here. So this is the nuts and bolts of chapter P3, prerequisite 3, inequalities. If you have any questions, please come to office hours and I will help you out. Email me if you have troubles, whatever. If you need help, you can reach me and I will be glad to help. Thanks. Bye.